So let's begin example number 2. And again, I'm going to do this with a calculator. So let me show you how to plug this thing into the calculator. So again, once it's turned on, we have to type in the function of this problem. In this case, we have a piecewise defined function, so we have to be careful how we type it in. So if you don't remember, take some notes and maybe rewind the video to see it again. So first of all, I'm going to plug in the first equation inside parentheses. So 2x plus 2 inside parentheses. Then I'm going to put the condition next to it. In this case, the condition is x is less than. So to get less than on my screen, I'm going to type second. Then I'm going to click the button that says math. That will put me in this test menu, and I want less than. The less than command is option number 5. So I'm going to go down a few times until I get to option number 5, click enter there. And then type in 1, close the parentheses. There's a second line in this function, the 2x minus 4. So again, repeat the same thing again, parentheses for 2x minus 4. Then the condition, which is x is greater than or equal to 1. So x greater than or equal to, so I'm going to go math again, and then greater than or equal to is option number 4. So I'm going to go down to option number 4, click enter, and then 1, close the parentheses, and then hit enter one more time. Now my table is still set up from the last example, the last problem we did. We set up the table so that it says ask on the first line and automatic on the second line, so that's great, that's what we want. So now we're ready to go. We're just going to go into the table. And if you have numbers already there, not a big deal. You could just clear them out by clicking delete, delete, delete. Or you can write directly on top of them. So you can type 0.9 and then hit enter. It will erase the old one and put a new one. And 0.99. And let me do all of them. So 0.999s and 0.4 of the 9s. Okay, so that's the end of that. Then I plug in the next few digits that we have in this problem, which are 1.001 and so on. So let me do that. Okay, so there we go. And the next one is 1.001 and then 1.01 and then finally 1.1. As you can see, the first few numbers in my table, 3.8, 3.98, 3.998 and so on, they all look like a 4. Whereas the second set of numbers, the other 4, negative 2, negative 1.998, negative 1.98, and so on, they all look like a 2, or actually a negative 2. So let's do this. The numbers in blue, they all look like a 4. How do I say that? The mathematical notation is this. The limit as x approaches the 1. Why am I writing 1? Because the numbers in green are all very close to 1. They all look like a 1 almost, but slightly less. On this function f of x is equal to 4. Okay, so again, 1 minus, because the numbers that we plugged in are all super close to 1, but slightly less. What's the reason for the 4? The reason for the 4 is because the numbers we saw at the end were all about 4. We're all roughly speaking 4. Now on the other side of the table, we plugged in numbers that were almost 1, but slightly more than 1. So all these guys that we plugged in were slightly more than 1. So 1 plus. And we use the function f of x, or rather, I keep writing f of x. It should be capital H of x instead. Let me fix it on the other one also. And what was the outcome on that answer? So on the second answer, when we did this problem, we ended up seeing negative 1.9998, negative 1.998, and so on and so forth. So they're all, let's say, roughly speaking, negative 2. So the negative 2 tells me the answer. Now, was the first answer that we got and the second answer that we got the same? The first answer was 4. The second answer was negative 2. They are not equal. So what does that mean about the limit without a plus or a minus next to the 1? So what number should you put in the middle? How many numbers can you think of between 4 and negative 2? There are tons and tons and tons of numbers. So therefore, we say the limit does not exist. There's not a specific number that goes in the middle. So we say the limit does not exist, and that's the answer to the question. So if I were to fill this table up, I would not be able to put anything in the middle box. It is impossible That's because the left limit and the right limit are not equal. Those two numbers were not the same at the end. That's the reason why we cannot say that there's a limit in this problem. Now, if I try to do the same thing again with the next part, if I plug in the 2.9, 2.999, and so on and so forth, I will see that the numbers on the left are all looking like a 2. So that means the limit as x approaches 3, because all the numbers I'm plugging in are roughly close to 3, but they're slightly less, so 3 minus, on this function h of x, all these numbers I'm plugging in are roughly speaking 2. So the limit is 2. On the other hand, all these guys right here tell me that the limit as x approaches 3 plus, numbers I'm plugging in are slightly more than 3, that's the reason for 3 plus, on this function h of x is also 2. So I found that the left limit and the right limit are identical. So what should I put in the middle? Well, it makes sense in this problem to say that the limit this time is going to be 2 also as well, because the left one is 2, the right one is 2, the middle one should be in the middle of 2 and 2, which is basically going to be a 2. So that one has an answer, whereas the first problem does not have an answer. And that's fine, that could typically happen.